All right, so we're getting into section 5.4, and this section is all about exploring the corresponding parts of congruent triangles and how they are congruent. And after today, or after this lesson, you should be able to relate congruence in terms of rigid motions, um, the corresponding parts of congruent triangles, and then you should be able to use the the corresponding parts of congruent triangles to write congruent statements. So first thing we just need to kind of clarify is congruence in terms of rigid motions. This kind of goes back to the last chapter, and so far we've kind of talked about congruence when we have two objects, say that those objects are congruent when they undergo rigid motions, and then after the motion, those objects maintained the lengths of all the sides are the same, and the measures of the angles are the same, and you can identify that those were rigid motions because those measures were all maintained. Well, we can define congruence in terms of rigid motion if two figures, we can say two figures are congruent if and only if there exists one or more rigid motions which will map one figure onto the other figure. So this is saying if I have, one figure, and I can like do a translation, right? That's a rigid motion, right? Or if I have I can make it just bigger, like rotate it. Say if I had to rotate this thing, 180 degrees, right? So if I had to rotate it back, 180 degrees, and then translate it, or if I had to, reflect it, that's a flipping horizontally, right? If I had to reflect it and then rotate it, right? But I had to reorient this, whatever way I needed to, but it didn't change the measures of the angles, right? Or it didn't change the lengths of the sides, and I was able to reorient this one way or another by reflecting it or rotating it and then translating it back onto the original image. So I'll rotate this, I'll reflect it back and then translate it back onto the original image, and you can see that all the angles and all the length measurements are the same. So that's the definition of congruence in terms of rigid motions. It's like these two images are congruent because there were rigid motions which was able to map them onto each other. So one thing that many people forget when saying that things are congruent is that it helps to mention rigid motions mapping onto each other. Lengths don't change. The measures of the lengths are the same. During the motion, the lengths don't change, and during the motion, the angles don't change. So that are some of the keywords that you want to mention in the definition of congruence in the terms of rigid motions. So those are some keywords and tricky phrases you want to mention in this. All right, so next thing we're going to do is a Cpctc, or the congruent parts of congruent triangles are congruent. I can go back here and get rid of these. So say I have these two triangles here, and I've already showed you that they're congruent. And let's say that I'll flip this one around a little bit, rotate it like 90 degrees right, but put it cut off because I didn't select big enough. So let's rotate this thing 90 degrees left. Okay, they're congruent triangles, right? And I'm gonna name this one like, this is, make it bigger a little bit. A, B, C, and then this one is going to be like, D, do like X, Y, and Z. All right. Well, I have to kind of figure out. Let me move this around a little here. Form, slip it through there, maybe bump it this way. There we go. So what is congruent? Which triangle is congruent to which? Can I say that ABC is congruent to XYZ? Well, that would be nice, but it's not true, right? Because if I look at line segment CB, right, it is not the same as line segment XZ, right? So let me figure out what is true here. So triangle A, B, C, I kind of have to like match the vertices up here, right? So I need to find the corresponding parts. I need to find the corresponding parts here. So what is the best way to do this? Well, I can map it. I can map it on top of that, right? So let's see if I can rotate around this thing. Right, so I kind of see if I can rotate this thing 90 degrees to the left. That would do the trick. Oh, but it didn't. I need to make it like move this thing over. Oops, move this thing over some more so I can grab this thing bigger. Make this thing like a bigger version of this. And maybe I can rotate this thing 90 degrees to the left. Okay, so now I can definitely see that these are congruent, and I could map it on top of these things. Now I could see that Y lines up with A, X lines up with B, and Z, that's a Z, lines up with C, right? So it'd have to be more like Y, Z, X, right? Because each vertex matters and each line segment matters because line segment AB is congruent with line segment Z. This is a Z, 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 Z. Looks like an N. It's a Z. It's just sideways. All right, so AB is congruent to YZ. That's what the single dash mark means, right? Single dash mark, single dash mark. Okay, and then CB is congruent to XZ. So, or BC, whatever way you want to say it. BC is congruent to X and Z, right? And then AC, it's not going to be shown on there because it would be like over here and over here, right? It's congruent to YX, right? So those are the three sides, right? And then you would say that vertex A is congruent with vertex Y, vertex C is congruent with vertex X, and then vertex B is congruent with vertex C. And you can mark it whatever order you'd like to mark it. It doesn't matter as long as they mark correspondingly. That's the corresponding parts are congruent. So the corresponding parts mean they're matching, right, on the triangle, and congruent means that they're like the two dashes are identify that there are two dashes, right? So this is true. Oops, put a triangle mark, right? So if you said triangle A, B, C was congruent to triangle X, Y, Z, right? That would be a big, fat, false statement, right? So just remember that the corresponding parts have to be congruent with the corresponding parts on the triangle. Okay, so that's what this whole thing is about, is identifying the corresponding parts. Okay, so let's get to a little bit of an exercise here with this triangle split up into multiple triangles. First, let's identify all the different triangles that we have. I'm going to draw a little pre-made triangle thing. Triangles. Yeah, and I'm going to kind of like get that ready to copy. And I'll fill it in with the colors that I need, I guess, later. Okay, so let's identify the different triangles that we have, and we'll just talk about what is congruent to what. And some these have to be, first off, when you're dealing with these things, there's going to be some givens to you at first. Otherwise, you can't just presume stuff. You can look at stuff, but you just can't presume stuff. And we're going to get a blast from the past here, and we're going to talk about some reflexive properties, and then we're going to say, hey, we're going to prove some of these triangles are congruent. We're going to talk about some of the corresponding parts are congruent. All right, so let's get talking right away. Right, so let's start with let's go from the top and work our way down. Right, so we have triangle. We'll just call this NGL. Right, so we have triangle NGL, and we're going to say that and we have triangle. Just copy that, and we have triangle. And we have triangle. Copy that. Paste it again, and then we have triangle NXL, which looks to be like a mirrored image, almost reflected across line NL. I'm gonna make that red as well. Fill block, fill block, like that N as well, right? So and this is line NXL, NXL. So my pencil, there it is. It's going to be NXL. Okay, so NXL, right? So if we said that these two triangles were congruent, right? We'll just give you that given. Okay, so the given is that these two triangles were congruent, right? Then you would be able to say that NGL, or you'd be able to see that line GN was congruent to XN, and then you'd be able to say that GL, that's not an L, GL was congruent to XL, right? Those are, and then, but this is also pretty cool. This is something that's going to blow your mind. You would also be able to say that NL is congruent to NL, right? Because that is the reflexive property. If you think way back to section 1 or unit 1, reflexive property, that something is equal to itself. And you're thinking to myself, when would I ever use that? Self. Well, that's when you're going to use that. Okay, and then you have reflexive, right? And then you have the different angles, right? So you have angle, LNG, angle LNG is congruent to, you guessed it, LNX, angle LNX, paying attention to the starting point, the vertex, and the ending point. Then you have angle let's do LGN. So we're going to do this one. This is my first angle. And then we'll do LGN. LGN is congruent to LXN. LX, angle LXN. That'll be our second congruent angle. Okay, and then the final one would be angle angle NLG, angle, oops, NLG is congruent to NLX, angle NLX, right? And that's our third angle for this red triangle set. All right, so it's pretty self-explanatory here. Okay. Right, so let's get into a little bit more of a complicated question here. How far back will this let me go? That's that far back, so that lets me go. Okay, that's good enough. I can work with this. All right, so let's say we're given we're given this. Okay, we're given these two things, and we're also given that we've proven this already. Let's say we've proven this in a different yeah, we use the side method on a subsequent problem to prove that these two triangles were congruent. Cool, right? We use the side method to prove that. And now we're moving on, and we're given that LGX, angle LG, or angle LGX, LGY, sorry about that, LGY is congruent to angle L, angle LXF, and we're given that, that's what we're going to do this, yeah, and then we're given that angle in that line segment LF, line segment LF is congruent to angle LY. What could we prove with that? Well, let's take a look. Right, so we got LGY is congruent to LXF. All right, and then we have LF. It's a new blue one. LF is congruent to LY. All right, well, what does that prove for us? Well, we have an angle. We have a side, and then we have another side. Well, what else do we know? Well, if these are congruent triangles, right? And so these are congruent triangles. What do we know about these supplementary triangles? What do we know about these supplementary triangles here? Oh, so if these are supplementary triangles, we know that these angles are congruent. Okay, and then if these angles are congruent, we're going to know that based upon the congruent supplement congruence or complementary supplementary congruence or supplements, we can know that these are congruent as well. Right, so because of this, we're going to know that we have two sets of angles. We actually know more than we actually need to know. We have two sides. We have a side, an angle, and a side, and another angle. These subsequent two triangles. So we can say we have an angle side angle or a side angle side for both of these two triangles. And then we can say that, so we can say that these triangles, say triangle YLG, triangle YLG, triangle YLG is congruent to triangle XLF. Oh, sorry, triangle FLX, triangle XLF. Right, because we can say we'll just say it's triangle, we'll just do it's a side angle side because of a side angle side theorem. Okay, so now we'll move on to the next one. We'll say that we have we know that LF and LY are the same lengths from the previous statement right here. And we know that and we'll say that we know that angle YDL, angle YDL is congruent to angle FDL. So these two angles are congruent. And then we'll say that we know that angle LFD, angle LFD is congruent to angle LYD, angle LYD. So this angle here and this angle here is congruent. So what do we know about, what can we deduce because of that? Well, because we know that this angle and this angle, we should make this like that. If these two angles are congruent and the opposite side of that angle is congruent, we know because of that, and this we have a angle side relationship. We can say that triangle DYL, triangle DYL is congruent to triangle DFL. All right. So let's see, let's fill in some stuff here. We had these triangles, and then we had these triangles again. All right, so now let's say we had these triangles here. We had a statement that we knew that line that ND is perpendicular to WR. And also I know that, let me think about this one for a second. Okay, I know that. Oh yeah, ND. Okay, of course, yeah. And I know that because reflexively ND is equal to itself. That is one. Just think about that. ND is equal to ND. ND is equal to or congruent to itself. ND. Okay. Well, and so, and I also know that WD is congruent to DR. Those are my givens. Congruent to DR. What can I deduce about these big, large triangles here? I need to grab this one. These big, large triangles right here. WDN and WDR. Well, because of the hypotenuse leg, there's a hypotenuse leg theorem, a hypotenuse leg theorem. I have one hypotenuse. Well, not quite yet. I would have to know the length of the hypotenuse. I would have to know WN. What I would need to know WN, and I would need to know NR. I would have to know that those. So this is not what I would need to know. I would need to know WN, and I would need to know NR to use a hypotenuse leg to see if these were congruent, right? So this is what I would need to know. I need to know this and this, and I would need to know that this was right hand angle, and because this is the shared leg, that is what I would need to know between the hypotenuse leg to use the hypotenuse leg. Figure out that one there. Okay, and then finally, to use say I've used side, 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 sides, side, side. I've used side, angle, side, angle, side, angle. Oh no, angle, angle, side. Now I need an angle, side, angle, right? So if I wanted to use this one, I would have to find like an angle, and a side, and an angle. So say I knew these angle, side, and an angle. Let's say I knew these three here, right? I knew this angle, this side, and this angle, this angle, this side, and this angle. Then I could be able to tell that these green areas here would be congruent. All right, so that is section 5.4. Kind of fell apart on me at the end there. Sorry about that. If you have any questions, please let me know. And I hope that my mistakes do not become your mistakes. And happy geometry.